Alright, so here's example number 3. We're going to graph this quadratic function here, but first let's identify the different parts of this quadratic. What we have next is we have a is equal to a negative 2, h is equal to a negative 2 before substitution, and then we have k is equal to positive 3. What do each of these three mean? Since a is negative 2, what that means that it is twice as steep as our parent function x squared, and then the negative sign, what that means is it's reflected across the x-axis or opens downward. Next we have h. We said it was a negative 2. What that means it is, this is prior to substitution, meaning that it moved to the left 2 units. It was translated to the left 2 units. Our last one is k. K is a positive 3, meaning that it was translated up 3 units. So we have a transformation. So if we're comparing it to our parent function x squared, this function is 2 times as steep. It's opening downward, shifted to the left 2 units, and up 3 units. So that's what we can expect when we graph it. Next thing we want to do is we want to write down the axis of symmetry. The axis of symmetry is x equals h, or x is equal to a negative 2, which is what we said h was from the beginning. Then we have, we want to pick two numbers that are smaller than negative 2. That way we stay on the same side. We're going to go with x equals negative 3 and x equals negative 4. Do a little bit of substitution using both of those. So we have g of negative 3 is equal to negative 2 times the quantity negative 3 plus 2 squared, that all plus 3. Put that in your calculator, we get that that is equal to 1. Then we're going to substitute a negative 4 into that same g of x function. Do a little bit of substitution. This is what it looks like. And then solve. You can go ahead and solve this by doing it by hand, throwing it all in your calculator. We get that that g of negative 4 is equal to a negative 5. So let's go ahead and fill out the table at the top with all of our values. Plot these 2 points and graph the axis of symmetry. So up here on the top right, we have x is equal to negative 3, g of x is equal to 1. That's our first point. When g of x is negative 4, g of x or y is equal to a negative 5. So that's just the second point that we're going to graph. The vertex is at hk, so let's go ahead and write that down, which is negative 2 comma negative 3. So we can go ahead and plot that there, and then use and also graph the line of symmetry in order to know where it's symmetric on the left and on the right. First point that came up, that was a vertex at 2, 3. Then we put a point at negative 3, 1, and the next point is at negative 4, 5. And here we go with the axis of symmetry. It's at negative 2. It comes up as a dotted or dashed line. It's a vertical line. X equals any number is a vertical line. So now we know that on the left, our first point is 1 unit away from that axis of symmetry. So it's going to be 1 unit on the right of that axis of symmetry. Go to the next point, negative 4, negative 5. That is 2 units to the left of the axis of symmetry. So it's going to be 2 units to the right of the axis of symmetry. This is where you have to do your best to draw a smooth curve through all those 5 points. Mine are not going to be that smooth, but we'll attempt it. There it is. And that is how you graph using AH and K. Let's see, the next example is example number 4. Example number 4 we are going to skip. So this one, skip this example. And let's move on to the next one. Pause the video, try this problem, and then we'll come back to this one. Here's your example in monitoring progress. We want to compare this function here with our parent function x squared. So let's see, here we go. First thing, let's go ahead and This is number 6. We want to go ahead and write down all of the information down. So we have that A is equal to 3, H is equal to A being A, it opens upward. We also have that it's since it's 3, it's 3 times as steep as our parent function. But we know that H is equal to 1, right? 1 prior to the substitution. So that means it translates 1 unit to the right. Also, we have that K is equal to 6. That means that the whole graph is translated 6 units up. Okay, so let's see. That's A, H, and K. What I want to do now is write down the vertex of our function. Our vertex is HK. So that means H is 1, K is 6. Our vertex is at 1, 6. See, the axis of symmetry, that's at x equals h. That means that x equals 1. That's where our axis of symmetry will be. It goes right through the x coordinate of that vertex. What we want to do is we want to choose 2 numbers that are smaller than h, smaller than 1. So we'll pick h. X is equal to 0 and do a little bit of substitution. So what we get is that g of 0 is equal to 3 times quantity 0 minus 1 squared plus 6. Do a little bit of math again. You can always throw this into your calculator. You get that this point is at 0, 9. So when x is equal to 0, y is equal to 9. Let's choose our second number. Let's go ahead and choose that x is equal to a negative 1. Substituting negative 1 into our function, we got g of negative 1 is equal to that there. Then we do a little bit of math, a little bit of PEMDAS, or you can throw it into your calculator. And then what you get is that when x is equal to 1, y is equal to 18. The only thing left to do is graph this function. So let's go ahead and do that. Here is, our graph doesn't have any x or y axis, so I went ahead and put the x axis way towards the bottom so we have more room to go up. Since this function is growing 3 times as steep as our parent function x squared. The y-axis should go right, kind of goes right up the middle. Looks like it is. And then, so then we continue from here. We'll go ahead and let's label our axes. This should go up by 2's, just so that we have enough room going upwards, since it's going to go up pretty fast. Let's see, so there is 2, 4, and 6, just to give you an idea that it's going up by 2's. The scale is by 2's. Same thing on the x-axis is scaled by 2's. Our first point that we have, see the vertex is at 1, 6. And there it goes in green. It's hidden behind that 6 on the y-axis, but it's there. And we have that graphed there. And let's see, the next one, our next point is 0, 9. That's right on the y-axis. So you can see it's going up into the left and up. So that is 0.09. Our next point is at negative 118. And then you'll see it pop up right 18. There we go. That's negative 1 all the way up to 18. That's why we dropped our x-axis all the way down to the bottom, giving us enough room to go up. So there's negative 118. Our axis of symmetry is at x equals 1. So we should go ahead and graph that one just so that we have it as a reference of where to put our other 2 points. Our first point, 0, 9, is 1 unit away from, on the left from our axis of symmetry, so it should go 1 unit right. Same thing with negative 118. That one there is 2 units to the left of the axis of symmetry, so we should put another point 2 units on the right of the axis of symmetry. And then the only thing left to do here is to do our best to draw a smooth curve through all these 5 points. And again, yours will probably look a lot better than mine, but there it is. Okay, so here we have monitoring progress number 7. Don't let that fraction intimidate you. We're just going to work with it. You'll see it's not that bad. All right, so let's go ahead and talk about what A, H, and k are about. So here we have a is equal to a 1/2. That means it's less steep than original function x squared. The next we have h. H is equal to a -4, and again it's -4 prior to substitution. That just means it's translated 4 units to the left. The next thing that we have is k. K is a -2, meaning that it was translated down 2 units. So how does this function compare to our parent function? First, it is less steep. It also was translated to the left 4 units and down 2 units. So that kind of gives you an idea of where that vertex is. Let's go ahead and see. What we have is the axis of symmetry. The axis of symmetry is x equals h, or x equals a -4, because that's exactly what h is. Next thing is what we want to do is we want to find that vertex. Finding the vertex is that it's at the point h comma k. We have all those, so we have the vertex is at -4, -2. The next thing we want to do is we want to choose two numbers less than -4, so we can start graphing our quadratic function. So let's start with x is equal to a -6, and the reason why we chose -6 and -5 is because when we do a little bit of math, we want to be able to divide by 2, and you'll see what I mean as we go through this problem. So we have is h of -6 is equal to all of that nice substitution there. What you can do is if you have a calculator, throw all that in there and get your answer, or you can do a little bit of math and work out the problem this way. And we end up with whenever x is equal to -6, y is equal to 0. So that's one of the first points that we are going to graph. Let's pick another number, and again we want to choose a number so that when we square it and subtract and do all that math, we want this to be able to be divisible by 2. So let's go with x is equal to -8. So we have h of -8, and there it is. That's what it looks like when we substitute it. Now we'll do a little bit more math, and again, if you have a calculator, what you can do is just go ahead and put it in your calculator and let the calculator do the math for you. So we have -4 squared is 16 times 1/2, subtract 2. We get that whenever x is equal to -8. We have y is equal to 6. So there's our next point. So we have the vertex is sitting at -4, -2. One of the points that this parabola goes through is at -6, 0. The other point is -8, -6. And so let's go ahead and begin graphing this parabola. There is our x-axis, and here is our y-axis. Our scale is going to go by 2, just so we can make it fit. And let's see, there is our axis of symmetry at x equals -4. There's our vertex, -4, -2, and let's go ahead and plot -6, 0 right on the x-axis, so that can be considered one of the zeros of this function. Then we go ahead and we plot -8, 6, and same thing like we did before. We want to see how many units to the left of that axis of symmetry these points are, and then do the same thing on the right, just because it is symmetric about that axis of symmetry, x equals -4. And let's continue. So the first point, -6, 0, is 1 unit to the left of the axis of symmetry. So when we plot the next one, it'll be 1 unit to the right of that axis of symmetry. There's another 0. So this one here crosses the x-axis in 2 different places. It has 2 zeros. Our next point is -8, 6 is 2 units to the left of that axis of symmetry. So when we graph the other point, it's going to be 2 units to the right of that axis of symmetry. And this part here, you want to make sure that when you graph your parabola, it's a smooth curve through these 5 points. And remember, this is a parabola, so it looks like a U. It looks like a U. And I'm sure yours will look a lot better than mine, but there it is. So A, H, and K, we figured out at the beginning. Found out the axis of symmetry was x equals -4. That's that dotted vertical line that we graphed. It's symmetric about that line on the left and on the right. Our vertex is at HK. -4, -2. Did a little bit of math to find out 2 points that this parabola goes through. And that is how you graph this function.